This work focuses on systematic investigation of low resource dependency parsing. I am Jivanesh Sandha. This is the joint work with Dr. Lakshmidhar Behra from IIT Mandi and Dr. Pawan Goyal from IIT Kharagpur. We focus on low resource dependency parsing for multiple languages. Several strategies such as data augmentation, self-training, pre-training, transfer learning, and multitasking are tailored to improve low resource performance, and they are well known to the community. However, we find that it's not trivial to select the best performing combination of these strategies. So we experiment with the 5 strategies mentioned above on 7 low resource universal dependency languages. In this work, we investigate how is the trend in performance of each strategy across various languages. Do all strategies contribute towards performance gain in the ensemble system? And can this simple ensemble approach outperform the state-of-the-art of low resource language? So we have put several constraints to select the languages for our experimentation. First, we selected the languages which contains less than 2500 training samples. So this is the plot of universal dependency languages against the number of training samples available, and this is the threshold. Next, we consider the languages that have explicit morphological information to accommodate the LCM pre-training. Again, we divided the existing languages into the 2 classes: languages which are covered in the multilingual pre-trained language modeling, and another category which are not covered. So in first category we got Arabic, Greek and Hungarian, and the next category Wolof, Gothic, Coptic and Sanskrit, and we eliminated the languages with no training data. This is our exhaustive experimentation on the 7 languages we built on top of the bioaffine architecture by Dozat and Manning. And here these are the 5 strategies that we are focusing, and in each strategy there are multiple variants we have considered, and finally the best performing variant of each strategy is ensemble in our final ensemble system. So all these experiments we have performed on the development set of respective language, and at the end the results are reported with the test set. So for the data augmentation, sequential transfer learning and multitasking, we found that the strategies are language dependent. We did not observe any trend in the languages. Then in self-training, we found that DCST variant outperformed in all the settings. In pre-training, we found the interesting observation. So languages which are covered in the pre-training of language model, so XLMR is outperforming, but in contrary, the languages which are not covered in the pre-trained multilingual language model, so there the LCM pre-training is helping. And finally, in our ensemble system, we found that languages where languages are covered in the pre-training, so only pre-training is helping and other strategies are not helping to improve the performance. But in contrary to that, the languages which are not covered in the multilingual pre-trained language model, so their pre-training, multitasking learning and sequential transfer learning, all these strategies are helping to boost the performance. Finally, we showcase the successful application of Sanskrit and report the state-of-the-art dependency performance. So this is our architecture. This is the LCM pre-training, and that we integrate using the gating mechanism in the bioaffine architecture. These are our results. We outperform the linguistically involved architecture with our simple ensemble architecture. So in conclusion, we focus on the low resource dependency parsing for multiple languages. Our ensemble system can benefit the languages not covered in the pre-trained language models, and our finding can help community to pick the suitable strategy for their language of interest and create a robust parsing solutions. And we will report the state-of-the-art performance for the Sanskrit. Our code base and data sets are publicly available to this link. Thank you very much.